Hey y'all, I wanted to take this opportunity to make this video going over factoring again quickly like we had in class today, and then talking about the next step where we would have our a value being greater than 1 or not equal to 1, and it's not a greatest common factor. But just as a quick review, what we talked about in class is that we can factor an expression, getting it to factored form where it's the product of our linear expression. So in the example that I have here, x squared minus 1x minus 6x, we would have x plus 2 times x minus 3. Now, how do we get there? Let's look at this first example 1, where we said that our first term goes in the first box, so x squared goes in area 1, and then 6 goes in area 2, or area 4, excuse me. Now, what we need to do is we need to figure out the factors of 6 that then add up and give us this 5x. That's what these two rows are going to add up to do here. So my factors of 6, I have 1 and 6, I have 2 and 3. So if I were to try 1x and 6x, when I add those together, that gives me a 7x. So that doesn't work. So I know that 1x and 6x is not going to work. So right off the bat, I can tell 1 and 6 are not my factors. So that means I'm going to try 2 and 3. I have 2x. I have 3x. That gives me a 5x. So that means on the outside, I know that x times x gives me that x squared. X times 3 gives me 3x, and then x times 2 gives me that 2x. So my factored form is y equals, and then it's the side lengths that we come up with, x plus 3 and x plus 2. Similar with example 2 here, x squared goes in that first box, the 16 goes in the fourth box. 16, sorry, a little goof there. So then what multiplies to give us a 16, factors of 16? Now it's a positive 16, and I'm trying to add up to be a negative 10. So that means whatever I pick here is going to have to wind up being negative in general. So I could have like negative 1 and negative 16, because multiplying those would give me positive 16, but then when I add them together, it's still going to be negative. I can have negative 2 and negative 8, negative 4, and negative 4. Now, I could plug those in here and figure it out. Because I'm looking at my list here, I can almost kind of come over here and say, well, I know that if I add these together, that's a negative 17. All right, that doesn't work. If I add these together, that gives me a negative 8. All right, again, that doesn't work. So obviously, I've got negative 2x and negative 8x. So we have x and x. So it is negative 8 and negative 2. Our factored form being x minus 8 times x minus 2. Now, what we also talked about is you might have a greatest common factor, referred to as the GCF. So in example 3 here, this means that I can divide all of my terms by the same number, in this case being 2. So I can take a 2 out of each one of these numbers. And then what that gives us is I have y equals, that 2 is factored out, and what remains is I have x squared plus 9x plus 18. This is what I'm now going to try to factor, the x squared plus 9x plus 18. So just like we did on the previous problems, I've got x squared in the first box, 18 in the second box. I know I'm trying to multiply to 18, that adds to 9. Just quickly, that would be a 3x and a 6x. So a positive 6 and a positive 3. When I'm writing my factored form, what I don't want to forget is this 2 that we factored in front, that greatest common factor. So it's going to be 2 times x plus 6 times x plus 3. And again, for example 4, GCF here being the 3. So I divide all of these by 3. I get y equals 3 is factored out. I have x squared minus 2x minus 8. Now, before filling this out, what I have seen students do in the past with some success, rather than forgetting that they factored out that 3, is they might go, okay, well, I know that my answer, I'm going to have that 3 in front, and then I'll have my parentheses there. So they will go ahead and say, all right, let me just go ahead and add this right off the bat, and I'll fill in once I figure those out. So we've got an x squared. I'm trying to make this negative 8x here. So I'm going to have a negative 4x and positive 2x. So that means we have x plus 2 and x minus 4. So our factored form is y is equal to 3 times x plus 2 and x minus 4. You could have a different order on that. Like you could say 3 times x minus 4 and x plus 2, because in multiplication, the order doesn't matter. But what we do want to make sure is that that greatest common factor is in front. Like it would look goofy if I wrote y is equal to x minus 4 times 3 times x plus 2. We always want that term out front there, that greatest common factor. Now, what happens when our a value is not our greatest common factor, and I can't reduce all my terms by something here? So this is when we have a quadratic function where our a value is either a prime number or it's composite. So what that means is, so we're looking at it. So I can't divide all these by 2. That would be really nice. What I do know is that this first box is made up of 2x. And the last box is 12. Now, before I try to start filling in this box 2 and 3 here, knowing that I have to add up to 11x, what I'm going to do is I'm going to say, okay, well, 2x squared, I know it has to be 2x and x along the outsides. Now, to make a 12, if I think about my factors of 12, I've got 1 and 12, 2 and 6, 3 and 4. What I'm going to start doing is, instead of filling out the inner parts, I'm going to start working along the outer edges, and I'll show you why I'm going to be doing that here. So let's say I started with 1 and 12, just using my first couple factors there. Well, if I did that, then this area would be 2x times 12, which would be 24x. And then this box would be 1 times x, which would be 1x, and that clearly is 25x. 25x. So that one doesn't work. Okay, so I know that 1 and 12 in those positions don't work. Does it work if I changed it up and I had instead 12 here and a 1 here? Well, that's 2x. This is 12x. I'm getting closer because that brought me to a 14x, but it's still not the right answer. So 1 and 12, I know, are no good. All right, let's bring it down to 2 and 6 now. So let's say this was plus 2 and this was plus 6. Okay, so this is 12x, this is 2x, that again is 14x, so no bueno. Let me switch those then. What if this is 4 and this is 2? Well, that's 4x, and this is 4x, and that gives me 8x. Annoying, right? Because we didn't quite get there. So 2 and 6, those are out as well. So now we've done process of elimination. We know it's going to be 3 and 4. If we say, well, maybe this is 3 and maybe this is 4 here, this is going to give us an 8x inside, and this is 3x on the inside. So then that does give me the 11x that I was looking for as that middle term. So with these types of functions, it's a little bit more of guess and check using that area model. But when you do this more with practice, it will become a little bit easier. You'll start kind of picking up patterns and identifying some different little tricks that you might kind of recognize on your own. But really, using this area model, we are able to come up with our factored form of 2x plus 3 and x plus 1. Um, the next example, 3x squared minus 11x plus 6. Again, not all of these are divisible by 3 or any greatest common factor in general. So I'm going to start filling out this area model. So I've got 3x squared here, squared, not cubed. And then I've got the 6 down in that bottom corner. So having it prime is nice because I know it's definitely going to be 3x and x. We're trying to multiply to make 6. So factors of 6, I have 1 and 6. I have 2 and 3. Now notice that I'm trying to make an 11 that is negative. So both of these are going to have to be negative. Negative 6 and negative 1, and negative 2 and negative 3. Because when you multiply negatives, it gives you a positive product. But then when you add them together, it's still going to be negative. So let's try to do a little bit of guess and check here. If I have 3x minus 1 and x minus 6, this is an 18x. This is a negative 1x. That gives me negative 19. Okay, that doesn't work. So let's switch it. Maybe let's do minus 6, minus 1. It's negative 3x, negative 6x. That only gives me negative 9. So, all right, that one didn't work. So we know that 1 and 6 are out. 2 and 3. Okay, so let's try negative 2 here, negative 3 here. This gives me negative 9x down in this bottom left box. And in the upper right, I have negative 2x. Oh, when I add those together, it gives me that negative 11x. Boom. Amazing. We did find it. So then our factored form is y is equal to 3x minus 2 and x minus 3. For our next example, this is when we have an a value where it's a composite, meaning that it's not prime. I have a couple different answers, right? How I can make 4 is it is 2 and 2, but it's also 4 and 1. So while I know that this is going to be 4x squared here, I could have this as 2x and 2x, or it could be 4x and 1x. So that's, again, where we might run into some headaches on this one if we're working with a composite. So let's just first start and say, let's try the 2x and 2x, hoping that this works out. It's nice that we're working with this negative 3 here because we know that that's prime. So there's only 2 factors for 3, negative 3, excuse me, are factors of 3. I know it's 1 and 3. So we're really just kind of playing around in these spaces here, trying to figure out is it 1 and 3 or 3 and 1? What do we got here? So if I said this was 3 and this was 1, now they're both doing 2 times that. So I know that this is 2x and this is going to be a 3x. So then, oh, excuse me, 6x. Haha. Silly. So now the question is, how do we make this negative 4? Well, this has to be a negative 6x then, which means that I need this to be a negative 3. So that means that the 1 is positive. So our factored form is y is equal to 2x minus 3 and 2x plus 1. And then example 4 here, we have 6x squared. So I'm going to write that in this box, 6x squared. We're making a 12. So factors of 12. 1 and 12. 2 and 6. 3, and 4. So 6x, again, it's a composite. So it could be 1 and 6, could be 2 and 3. Let's try the 2 and 3 first, because that happens more often than 1 and 6. But, it always just depends on how this problem is set up. So 3x and 2x is what we're going to work with here. So I'm going to start with numbers that are closer together just on this one. There's always some different thinking of which ones to start with. So let's say I made this positive 3 here in the bottom left and a positive 4 up here. So this is a 9x here, and this is going to be 8x. Oh, well, that gives me that 17x right away. That's nice. I kind of fell into that answer there. So I get y equals 3x plus 4 times 2x plus 3. I welcome you to try these 3 examples that you have there. The answer key is posted in Google Classroom. And then one last type that I want to talk about, these so-called special cases. We have perfect square trinomials, and then we have difference of squares. Now, in these, our a value is not 1, not always, but in this particular one, our a value is 1. So what I'm looking at here is just the regular factoring that we've done. We know that this is 1x squared, and we have 49. Now, what makes this a perfect square is that to make 49, I know that I either have 1 and 49 or I have 7 and 7. And if I know that it's going to be 7x and 7x, and it's making that negative 14x, it's going to be negative 7 and negative 7. So my factored form for this is x minus 7 times x minus 7, or what we have been writing when we've been doing completing the square and vertex form was that compressed version of x minus 7 squared. So that's the example of a perfect squared trinomial, where we recognize that that last term is a perfect square. The sum of my terms being that middle, having to pay attention to that sign, and trinomial meaning that we have 3 terms in this. And then for difference of squares, the difference is referring to that there's subtraction in the middle. Now, what you're going to see with difference of squares is that you will have only 2 terms. And they are both perfect squares because this is a 1x squared and 1 is a perfect square. 1 times 1 and the square root of 1 is 1. And then 16. Now, how this works is that I have my x squared and we have negative 16. Well, how do I make negative 16 if I think about it as a perfect square? I know that it has to be 4 and 4, but to make negative, one has to be a positive 4 and one has to be a negative 4. Because then I have negative 4x and positive 4x. Now, when I add these together, that gives me 0x. So that's why we don't see that b term if we think about it as standard form, right? It'd be goofy if I wrote this as x squared plus 0x minus 16. Like, why would we even include that 0x? But when I write it as factored form, I still have my side lengths of x plus 4 and x minus 4. So those ones are pretty quick when we're talking about difference of squares. Please try these remaining problems that are on your worksheet there. And then answer key obviously will be posted in Google Classroom. As always, feel free to email me to ask any questions. We'll keep working on this next week as well. Just introducing this concept today. You just need some more practice with it. Thank you.